So now we will explore the following situation: maximization problem. Always the function integral of t x and x prime dt over the set u. This time u is the set of functions in C1 over the interval t0 t1, where the initial condition is known, is given, but for the second we impose an inequality. We want xt1 greater than x1, given limit x1. So this is the kind of category of problem we want to study. Sorry. So this is the kind of problem we want to study here. Okay. It's not necessary to cover. It's okay. So let's continue. So here is the as usual, the necessary conditions we have. We need to know them so that we reduce our set of search. Instead of searching in the set U large as it is, we are reduced to work in a small set of functions. So if x is a solution, solves the problem, then necessarily we have Euler equations that are satisfied. So dx dt, then let's write it here, or here. Then we will have Euler equations. So df dx minus d dt of df du applied at tx x prime equals 0, which is Euler equation. Necessarily we look for, and we have another condition that appears. It is this one: df du applied at tx x prime. Sorry, here x and x prime. Okay, at t equal t1 is negative with df du, okay, applied at tx x prime at t equal t1 equals 0. They appear naturally if we try to solve the problem. If x at t1, okay, so here at everything is applied at tx. So instead of putting star, I will leave it like that. Understand? I'm dealing with this function candidate. Then xt1 is if xt1 is strictly greater than x1, and this one is the transversality condition. Okay, transversality condition also. Okay, so this is what we need to check. If that means, if we are looking for a candidate for optimality, necessarily solve these two equations and find your candidate. Now we have sufficient condition that says that if you have x satisfies Euler equation and the transversality conditions, then yes, then, and no, before that, and if f is concave in xu, then x solves the problem. Okay, so here, yes, it's similar at the other situation, just the new thing is the transversality condition, it's new. So let's have a practice through an example, the problem, solve a problem. Okay, so here it is, it starts an example. So the example we want to consider is the following. Solve the maximum integral 01 10 minus x prime square minus 2x x prime minus 5x2. Okay, there is an exponential minus t dt. Okay, over u. What is u here? U is specified is the set of functions. Or I look in this set. I decided yes. They gave us the condition, initial condition, but that's so we will look at that for them here on the interval 0, 1. So the integral suggests the interval, and they gave us the initial x0, it must be 0, and we want a condition at x1 greater or equal to 2. So we have a problem similar to the one set here. Okay, so let's proceed as we did, yes, as usual. We identify first our function in u, so it's 10 minus u2, 2xu minus 5x2. I will need partial derivatives of f, so it will be minus 2u minus 10x. Okay. Oh, sorry, I forgot something. A minus t. Okay, so yes, there will be a minus t here. Fu will be minus 2u minus 2x a minus t. Okay, what else? Now ddx, yes, that's all. And my functions, so yes, g, I can introduce g of x is the integral from 0 to 1 of ftx u x prime dt. So this is similar to what we are. Okay, now so the first thing is to check interpret the Euler equation. So I will need to fu express fu at tx x prime, so it will be minus 2x prime minus 2x a minus t. Then if I want the derivative of this term tx x prime, so I will have to derive the products of two functions. Okay, so I will have let's keep minus 2 as factor, so I will derive the first function x second minus plus x prime a minus t, then plus x prime plus x and minus a minus t. So this is my derivative. Now let's write Euler equation. Okay, so let's write them here to save space. Euler equation, so let's write them here. So I need to check fx minus d dt of fu. I apply that to x prime. Okay, equals 0. So fx, we said it's minus 2 at x. Of course, fx also is applied at tx x prime, so minus 2 x prime minus 10x a minus t minus d dt. We found it here, so plus 2 times a minus t common factor, and I will have x again plus x prime minus x prime, so cancel, then plus x only. No, minus x. So minus x. Okay, so is it that? Yes. Okay, so this is, we want it to be 0. Okay, so if you look this term also x prime, that's all. So we will have the equation is reduced to, we can simplify by 2 and a minus t, so we will get x second, so we can cancel, so we will get x second minus x and minus x prime, and here minus 5x equal 0. So finally I have an equation in type x minus 6x equals 0. So I assign the equation r squared minus r minus 6 equals 0, and I can find two roots, and we have two roots, r1 equal 3 and r2 equal minus 2. So the general equation for this equation is xt. So let's write just the general equation solution. So xt will be, or write it in red. So from the equation, yes, we have then xt, we found it is a exponential 3t plus b a minus 2t. Okay, from Euler. Okay, now we need to exploit the transversality, interpret the transversality condition. So we have it here, and let's try to apply it then. Okay, so let's now express the transversality condition. Okay, so we said, so we have, if, let's discuss is if x1 is greater than 2. Okay, so then we should have fu at x prime. Okay, so but the value, this value, we have it here it is, we apply it at t. Okay, at t equal 1, so it is the quantity minus 2x prime plus minus 2x a minus t to t equal 1. We wanted 0 equal 0, but what is it, this one? That is minus 2a minus 1 x prime 1 plus x1, okay, equals 0. So what is x prime? So we have the general solution. It is written in the form a 3t plus b a minus 2t. Okay, I didn't express one condition. Let's use first x0. x0, we said it is 0, but x0 gives me a plus b. We wanted 0, so b necessarily is minus a. So xt is reduced to a times a 3t minus a minus 2t. It's much simpler to, now we derive x prime t will be then a times 3t plus 2a minus 2t. If you take the value at 1, so you should have 3e3 plus 2a minus 2. So we want, and x1 also, x1 is a3 minus a minus 2. So if we add them, x prime 1 plus x1, we will get a 4a3 and plus a minus 2. So we want yes, so this condition is satisfied, equal 0 if and only if a equals 0. Okay, but then if a equals 0 but with a equals 0 we have x1 that is 0, which is not greater than 2, so impossible. So we cannot, so necessarily we cannot have x1, so we cannot have, let's write it like that, so we cannot have x1 is greater than 2, thus x1 is equal to, okay, from which we deduce a equal, so a we know that x1, what is it, x1, here it is x1 is this one, equal 2, so it will be 2 over a3 minus a minus 2, and yes, and xt then we know it, yes, xt will be then this constant, and a3t minus a minus 2t, okay, over e3 minus e minus 2. Let's check now if, because transversality condition, there are two parts. If we have this, okay, and here we decided, but we need to check then that the partial derivative, this partial derivative is less than 0. But check, so check that fu at t x prime at t equal 1 is negative, but the fu, it's just fu, yes, it's these quantities, so it's minus 2 x prime 1 plus x1, okay, a minus t, and but x prime 1 plus x, we know it's this number, it's this quantity. Okay, so it's minus 2a for a3 plus e minus 2 e minus t, and e is positive, so this is, yes, is strictly negative, so it is true, it is satisfied always. So finally, yes, we found, so what we did, we identified a candidate point, so xt is a candidate point, this one is candidate. To check that it is a solution, that it's solved for, we need to check the concavity of our concavity of f in xu. So we have our f partial derivatives, we have them here. So we have them here. Here is fu, here is fx, they are not simple ones, so let's write them back here. So we have fx, so fx, do we have them here? Do I have them? Okay. So fx, so I give you, so fx was, yes, we found fx was minus 2u minus 10x a minus t, and fu was minus 2u minus 2x and a minus t. So the ACN of f would be fxx, if you derive with respect of x, we will get minus 10 e minus t. With respect of u, we'll have minus 2 e minus t minus 2 minus t, and fuu minus 2 e minus t. And clearly d1 at t at xu as a function of xu is minus 10 e minus t minus 1 d1 is positive, and d2 xu is 20 e minus 2t and minus 4 e minus 2t, which is 16 minus 2t, which is positive, and d2 minus 1 square is positive. So yes, f is concave in xu for in xu belonging to R2. So x star t defined by that we found, the candidate we found, it's 2 times e3t minus e minus 2t over e3 minus e minus 2 solves the maximization problem. Maximization problem. Okay, so here is how you can proceed in applying the problems in this way, formulated in these under those conditions. Okay.